Ever think about like all the invisible stuff around us?
Yeah.
Not just thoughts and ideas,
Right.
but little tiny bits of matter,
Mm-hmm.
like floating everywhere. I mean, sure, we see dust sometimes, or if you've got allergies, pollen,
Oh, yeah.
but there's a whole world of particles, even smaller, totally invisible,
Oh, yeah, definitely.
that can have a huge impact, especially when you're dealing with like sensitive technology.
Absolutely.
And that's kind of where we're going today. We're doing a deep dive into a system for tackling, well, those unseen threats, basically.
We're looking at the Air Six-Free Maze Purification system,
That's it.
and it's all laid out in U.S. patent number US-8268058-B2. Quite a mouthful.
It is. It is. So this is for anyone out there who's ever wondered, how do they keep the air in certain places so clean?
Yeah, good question.
Or even if you're just fascinated by how we push the boundaries of technology,
Mm-hmm.
then stick with us. Today, our goal is to really get down to the nuts and bolts of how this system works. And, particularly why the inventor is so convinced that this is vital, especially for something as precise as making computer chips.
Yes, especially semiconductors, the really advanced kind.
Yeah, exactly. And we're not just, taking marketing jargon at face value here.
Right.
We've actually got the engineering explanation,
Straight from the patent.
straight from the horse's mouth, right from that patent.
Yes, all the technical details.
It's out the mechanics.
But we also have something else.
Yeah.
A letter from the inventor himself expressing some serious concerns about possible patent infringement.
Okay, so we've got like the technical side and then the real world drama.
Yeah, exactly. We see how this stuff actually plays out.
All right, so let's break down this name. Air Six-Free Maze Purifier. Kind of a mouthful, but it hints at what it's going after.
Yeah, 6 main things it wants to eliminate: dust, germs, toxins, smoke, odors, and heavy metals.
6 airborne baddies.
But the real question is, how does it actually do it?
Yeah, right. What's the magic here?
Maybe we should start with how the air actually moves through the system. That's where the real ingenuity is.
Okay, lead the way.
So the patent describes this fan at the top of the unit, and get this, it blows clean air outward at an angle.
Outward.
Yeah, I know, it seems counterintuitive at first.
You'd think it'd be pushing the dirty air around.
Right, but this outward flow is crucial because it creates suction from below.
Oh, I see.
So it pulls the contaminated air into the system.
So it's actively drawing the bad air in from the bottom.
Exactly.
Gotcha. So where does that air hit its first roadblock?
That would be stage 1, initial filtration. You've got your standard filter there.
Okay, basic filter.
Think of it as the first line of defense. Its job is to catch the larger particles, things like dust, hair, pollen.
Got it. So not the microscopic stuff yet.
No, not yet. But the stage is super important because it protects those later, more delicate stages.
Right. You don't want those getting clogged up with big junk.
Exactly. Now, things get really interesting after this initial filter.
Okay, this is where the maze part comes in,
But
right?
not quite yet. First, we have stage 2,
Oh,
ionization, before the air even enters the main chamber.
interesting. Ionization. Okay, break that down for me.
So there's this negative ion generator pumping out a mind-boggling amount of negative ions.
How many are we talking?
20 million every second.
Wow, 20 million. That's a lot of ions.
Yeah.
What are those doing exactly?
They act like little magnets. They attach a negative charge to those ultrafine particles in the air.
So, like giving them a little electric tag?
Exactly. It makes them easier to catch later on.
Makes sense. Okay, so these tagged particles are moving along, then what?
Then they hit stage 3.
Ah,
The
tag.
labyrinth. The air flows into this sealed, four-sided chamber, but it's not a straight shot.
Okay, so it has to navigate this maze.
Exactly.
And this is all happening inside this sealed unit, right?
That's key. Sealed environment for controlled airflow.
Makes sense. So the air is in the maze. It's been ionized. What's next?
Stage 4, electrostatic particle capture. This is where the magic of opposite charges really shines.
Yeah. Okay, the physics coming into play.
The walls of this maze are lined with metal tubing, and it's positively charged.
And the particles we tagged earlier are negative.
Exactly. So those particles are attracted to the walls.
Opposites attract. Basic science, right?
Exactly. Plus, these tiny particles, they naturally stick to larger surfaces.
Like static cling.
Yeah, just like that.
So the maze walls are basically giant sticky traps.
Pretty much.
But the maze isn't just a straight tube, is it? There are turns, right?
You're right. And that brings us to stage 5.
Okay, what happens at the turns?
It's all about inertia.
Okay, that's the thing where an object wants to keep moving in the same direction.
Exactly. So the air, being a fluid, can easily follow the terms in the maze.
Right.
But those tiny particles, because of inertia, they want to keep going straight.
Ah, so they slam into the
You
walls.
got it.
Mm.
And since the walls are positively charged, the particles get captured.
Clever.
Yeah.
But it's a combination of attraction and those inertia-driven collisions.
Exactly. That's how you achieve 100% purified air.
100%, wow. And that includes PM.3 particles.
Yeah, those are tiny, way smaller than what we can see with the naked eye.
Okay, so we're talking about removing really, really small stuff.
Right, stuff that can get deep into your lungs or mess up those sensitive computer chips.
And all of this is happening just through the design of the system.
Yeah, it's what they call simple physics, no harsh chemicals, no plasma, no UV light.
Elegant. But now let's switch gears and talk about the inventor himself and his concerns.
Yeah, we have this letter he wrote, Letter to Brothers, addressed to those semiconductor companies.
Right, and right off the bat, he makes it clear that he's not angry, just wants to set the record straight.
He thinks a lot of companies are infringing on his patent.
Maybe unintentionally.
Could be.
He sees himself as the inventor, not a troublemaker.
Right, trying to point out an oversight.
Okay, so what's the heart of his argument? Why is his system so important, especially for making these advanced chips?
He says the problem is with ULPA filters.
Those are the industry standard, right?
Ultra-low penetration air filters. Yeah, they're great at capturing particles 120 nanometers and up.
But he's saying they're not good enough for the really tiny stuff.
Exactly. Anything at or below 14 nanometers.
And that's where those advanced semiconductor processes come in.
Right, think 14 nanometer, 12 nanometer, 7, and even smaller.
So he's saying the very foundation of clean rooms might be flawed.
Potentially, yeah.
Interesting. And he's claiming his system is the only solution.
The only one scientifically proven to deal with those ultrafine particles, he says.
Including toxins and even sub-nanometer contaminants.
All essential for maintaining yields, he argues.
Yields being how many chips they can successfully make.
Exactly. Now, he doesn't just make general claims, he points to specific examples.
He even names names.
Samsung in particular.
What's his evidence there?
He points to the well-documented problems Samsung had with their 14 nanometer process.
Their yields were really bad, everyone knew.
Then they switched to 12 nanometer and boom, problem solved.
But they didn't announce any radical change in air purification.
Exactly. So he's implying they might have quietly adopted his technology.
Without giving him credit.
Possibly, yeah. Now, it gets even more interesting. He used AI to analyze the industry-standard clean rooms.
AI, like ChatGPT.
He used ChatGPT and Gemini, both of them.
And what did the AI tell him?
They confirmed that even the most advanced clean rooms still rely on ULPA.
Okay, they might have other measures, but ULPA is the core.
That's right. Laminar airflow, HEPA pre-filtration, all that.
But ULPA is still the bottleneck, according to the inventor.
And the AI seems to agree.
Interesting. And to really drive his point home, he includes these comparison charts.
Yeah, those charts are pretty compelling.
The first one shows how ULPA just falls apart at those smaller sizes.
Even with all their tricks, he says.
Right. And his system, it keeps performing even at 0.01 nanometers.
A stark contrast.
The second chart then just lays it all out.
No way to get those yields below 14 nanometers with just ULPA.
His system is the only game in town, according to him.
That's his claim.
Now, there was this claim, I think, from TSMC that their processes don't produce any particles.
Yeah, I remember that.
But he's skeptical.
Well, he says it goes against basic science.
The conservation of matter.
You can't create something from nothing.
He's basically saying any manufacturing process, especially one this intricate, is going to produce some kind of particles.
Chemical residues, byproducts, something.
So those no-particle claims, he's not buying it.
Not without a really good explanation.
And that leads into his concern that companies using TSMC chips might be unknowingly infringing.
Right, if TSMC is achieving those yields at 14 nanometers or smaller.
And they haven't said anything about a new technology.
He thinks it's likely they're using his patented technology without a license.
And anyone using those chips would be caught up in that.
Yeah, because they're benefiting from something potentially made illegally.
So he ends his letter with a pretty clear message.
He's putting everyone on notice.
Any company working at 14 nanometers or smaller.
They might be violating his patent.
He even says he's open to licensing agreements.
Yeah, he wants to talk.
It's a firm, but I'd say respectful call to action.
Definitely. He's laying down the science, laying down the law.
Urging the industry to take notice.
Yeah.
All right, so let's recap for our listeners. We dove deep into this Air Six-Free Maze Purifier.
A system using basic physics to clean the air.
taking out even the tiniest particles,
And we saw how the inventor believes this is crucial for the future of chip making.
with some serious allegations of patent infringement.
And some big questions about the industry as a whole.
What strikes me is how this system uses simple principles in a really ingenious way.
Yeah, like taking physics from the textbook and turning it into cutting-edge tech.
Makes you wonder how many other invisible challenges are being solved in ways we don't even know about.
Right, or what happens when a key technology is used without permission.
It really makes you think about innovation, intellectual property, the whole shebang.
Yeah, it's a complex world out there.
And who knows, maybe this has piqued your interest in cleanroom technology.
Or the physics of filtration.
There's a whole rabbit hole to go down there.
Definitely.
Well, that's just the tip of the iceberg. Thanks for joining us on this deep dive.
Until next time.
Keep exploring.
Indeed.
See you later.
Take care.
Bye.